Hello everyone, this is Group P5. The topic of this video is Programmed I/O. These are the topics that will be covered in this video. There are three techniques for I/O operations. The first is Programmed I/O, second is Interrupt-Driven I/O, and the third is DMA, Direct Memory Access. Programmed I/O does not use any interrupts and there is I/O to memory transfer through processor. With Programmed I/O, data is exchanged between the processor and the I/O module. To execute an I/O related instruction, the processor issues an address specifying the particular I/O module and external device and an I/O command. There are four types of I/O commands that an I/O module may receive when it is addressed by a processor. The first is control, second is test, third is read, and the fourth is write. Let's take a brief look at these commands. The control command is used to activate a peripheral and tell it what to do. For example, a magnetic tape unit may be instructed to rewind or to move forward one record. These commands are tailored to the particular type of peripheral device. The second, test command is used to test various status conditions associated with an I/O module and its peripherals. The processor will want to know that the peripheral of interest is powered on and available for use. It will also want to know if the most recent I/O operation is completed and if any errors occurred. The third, the read command causes the I/O module to obtain an item of data from the peripheral and place it in an internal buffer. The processor can then obtain the data item by requesting that the I/O module place it on the data bus. The write command causes the I/O module to take an item of data, byte or word, from the data bus and subsequently transmit that data item to the peripheral. So these were the four commands. Now let's take a look at the flowchart.
So now I will explain you the instruction cycle of programmed I/O. The CPU first issues read command to I/O module. After that, it reads status of I/O module. Means it checks whether the I/O module is ready to send the data to CPU. If an error occurs, means the I/O module is busy doing some other work, so it is not ready, then it again reads the status of I/O module until it is ready. Now, suppose the I/O module is ready to send the data, then the CPU reads the data from I/O module. After reading, the CPU executes the instruction or it sends the data. That is, it writes the word into memory. So if it is done, it goes to the next instruction. But if it is not done, it goes to the starting step. Here, the CPU has to wait until the I/O module is ready. And this is one of the drawbacks of programmed I/O. So if the CPU is faster than the I/O module, then the method is wasteful. Main concept behind the programmed I/O is transfer of block of data from I/O devices to memory through CPU. Now, when the processor main memory shares a common bus, two modes of addressing are possible: memory mapped I/O and isolated I/O. Memory mapped I/O. The processor accesses memory and I/O using the single address space. Here, the processor uses the same address, data, and control bus. So, the same set of machine instructions addresses both memory and I/O. Now, I will tell you about the isolated I/O. When isolated I/O, the address space for memory is isolated from the address space of I/O. Through the processor uses the same data and addresses line for memory and I/O devices, it uses a separate control line for memory and I/O devices. Next, I will tell you about the advantages and disadvantages of programmed I/O. First, the advantages are it is simple to implement, very little hardware support is required. Disadvantages: busy waiting and ties up CPU for long period with no useful work. Thank you.